Okay, so energy. Energy is not something we can create or destroy. Energy can only be converted. When we think about hydropower, we have the hydropower potential as river flows. We convert it into electricity by using the energy in the flowing river through turbines and generators. And then, for example, when we have fossil fuel in our vehicles, in the internal combustion engine, it has an efficiency of only 20%. That means 80% of the energy content in the fossil fuel is actually wasted to heat. So we convert energy to levels which we cannot use it anymore. Waste heat from the engine in a car cannot be used. If we have a big engine like a turbo engine in an airplane, it has actually waste heat recovery, which then is used to heat the cabin, for example.
Yeah, and turbochargers on cars as well.
Yeah, so it's possible to use this waste heat from different energy conversion or energy generation, but not in all cases. In many cases, it's just wasted to the environment, heating the environment, or we have air pollution, which affects, of course, the air in a city. We're not only talking about climate change. Fossil fuel burning has many other impacts on our environment as well. So energy cannot be created. And then we want today to try to see energy as a system. And a system, there are many definitions, of course, what a system is, but this from Young in 1964 says a system is a set of objects or components together with relationships between these objects and between their attributes. And in a very abstract form, you could depict it as the picture here on the right-hand side. When we talk about system, we usually want to like limit our scope. We create artificially ourselves a system border. When we look at the community, at the village, the geographical area of the village is our system border. We can look at an energy system of a building, then the building itself, the building envelope to the outside environment is our system border. And then, of course, we have the environment which affects or impacts on our system. The temperature, for example, the rain and wind. In a national energy system, the environment would be like global energy prices, oil prices, then electricity prices, which are also affected by import and export, not only by what we generate locally. And then, of course, we have all the components inside, within the system, which we will look at in the next slide. Now, imagine we are looking at a city or a bigger community. Then one of the components could be a CHP plant, a district heating plant, which also produces electricity, combined heat and power. The energy comes from biomass, and the biomass is, again, use of forestry or agricultural residues, which could be created within the system of our community, or it is imported from the outside. And then within our system, we have buildings and users. Buildings have, again, themselves, oops, now I pressed the wrong button, I'm sorry. Buildings, again, have heating systems, and they can also be integrated systems. You can have a solar thermal system on the roof, which is integrated with your boiler, and the boiler is biomass heated or peat heated, or also integrated with a heat pump. So here again, we have a system view of a heating system. And then, of course, the envelope or the system is in a building is determined also how it is built up by the current building regulations, or by the then current building regulations when the building was actually built. Was it built before 1990 or later? Or we will have a look at that as well. We can have hydropower, small hydropower within the systems, or we have hydropower on national level, which feeds into the electricity grid. And the electricity grid is actually also getting from outside into the system. We have the transmission and the distribution lines. We have the electricity utility, which operates within the system with the responsibility of distributing electricity to all the households, to commercial use, to industrial use. But buying perhaps electricity from a national supplier. I think also Ireland has a quite privatized electricity sector. I think different generators, then you have a system operator for the transmission grid, and then you have local distributors. Yeah, and then we have more and more local production on a building, like solar PV on the rooftop or ground mounted. We can have 1 or 2 soccer field size solar PV systems, like about 2 soccer fields give 1 megawatt about in Sweden at least. In Ireland, probably similar. And yeah, we also have not only buildings as users, but workshops and industries, public buildings, commercial buildings, etc. So this is like it gives a whole picture of the community on energy use and energy supply from local resources, but also what we import from outside our system border. And of course, with pictures like this, most of us are more familiar with. We see the whole city with, that could be a district heating system, a CHP plant, a factory which could provide waste heat to the district heating system. We have solar rooftop, we have a battery backup here. We have perhaps a future hydrogen electrolysis system, etc., etc. So there are different possibilities, of course, to describe, to put the energy system on the paper. Another description is like sun-key diagrams, which actually show energy flows from left to right, import and indigenous, it is said here. This is actually a sun-key diagram about Ireland. We have a lot of import, which probably oil and gas, a little bit of coal, and then we have local production. Biogas, bioenergy, like forest residues, peat, I guess, is also part of it here, and wind and other sources. And then it ends up on the different user sectors, transport sectors, residential sectors, industrial sectors. It's not very clear, this picture, but I think you get the idea of like presenting energy flows from the energy supply, primary energy sources to the user side. And then when we talk about energy system, we can also go even wider. Nation is only one possibility of a system boundary. We can also look at the EU 28, at the heating sector, which was actually done by Aalborg University, which used energy plan to actually model the heating sector in whole Europe. But I think most of us are most familiar with, let's say, a building. A building as an energy system. When we look at this, we have the building envelope, like all outside walls, including windows, which are usually a source of loss, heat loss. The roof, including the insulation, if we have well-insulated roofs. The heat, of course, as we know, warm, hot air is going up and escapes through the roof. So if we invest into better insulation, we should first look into roof insulation. And then, of course, we have energy gains also through the envelope. We have energy gain through the south side windows and walls. Then we have heat supply, in this case through a heat pump and an earth heat exchanger. We have electricity supply from the outside, but we can also have solar thermal or solar PV on the roof. So when you think about energy system, we have a perfect energy system here. We have users, we have producers, we have different energy sources, electricity, peat perhaps, the environment for the heat pump, solar gains through like passive gains and active gains, etc. So another possibility to look at an energy system. just picking out the heating itself as a system. A lot of heating energy sources is biomass, can be forests, can be agricultural residues, can be peat. How much peat is actually still used in Ireland for heating? Is it still a huge sector? Yeah.
In the countryside, especially.
Yeah. So it's still in use.
In some areas, they've banned the cutting of logs.
Yeah.
But in other areas, they haven't.
Yeah, I understand there are policies which try to reduce peat because it's how to say a slow renewable source, and slow means about 1,000 years, something like that. Yeah, and we need to achieve our climate targets in 2050 and 2100, not in 1,000 years. So this is why it shouldn't be used right now. Then, of course, we still have fossil fuel use in Ireland. This is a gas refinery, I think, and there is also some coal and oil use in the heating sector, as I understand. And then we have, when we move to the right-hand side, we have on the user side, we can produce heat from solar thermal systems. We can install heat pumps, air-to-air heat pumps or ground source heat pumps, which heat our water or heat air or provide heating, space heating. This is an example from Sweden, a very small local district heating system utilizing wood chips from a local small farm and providing heat to just a few buildings like a school, an elderly home, and the farm itself and a few other buildings. And then we have I think it's a pellets boiler in an apartment building, which replaced an oil boiler just recently. So this is system heating from the supply, agricultural, forestry, residues. Then we have, of course, transport and distribution, storage in between, and then the end use. Replacing perhaps a peat boiler or an oil boiler or coal boiler, whatever you have. Natural gas, I think, is also quite common in Ireland, as I understand, isn't it? Yeah. Okay. When we look at electricity, we have hydropower. Sweden is a big hydropower country, Norway, but also Ireland has a quite significant share of hydropower. And there is still potential in the hydropower system, I think, more rivers and hydro pump storage which can be developed. We have offshore and onshore wind, large-scale developments. We have still, of course, coal and gas power plants, which then distribute over the big power lines in the larger areas. And then we have the local distribution on different voltage levels. And then it finally ends up in our industries, commercial and then bigger industries, to become useful energy. Or it provides electricity to our homes where we use it for cooking, hot water, cooling, entertainment, communication, etc., etc. And more, many households become also prosumers or producers of electricity. So again, another view of an energy system. I think it's worth to repeating it. It's from another energy systems model, which Ireland also has developed. I'm not sure now who has developed that. EPA, is this the Environmental Protection Agency? I think they develop a TIMES model, which is a much more complex model than energy plan. But the principles are the same. They look at the demand side. What demands do we have from industry, from commerce, from residential areas, and then they put them together in the sectors, industrial, commercial sectors, etc. And then how is this demand then supplied by coal? We need refineries, we procure crude oil, and then we process crude oil in refineries, supply it to the transport sectors, etc. And then we have domestic sources and imports. So that's just another way to go again from supply side to demand side, or when you read it from right to left, from how much energy do we need and how then do we supply it in the most efficient way and most environmental friendly, sustainable way. And again, energy plan. I see it in one of the screens over there. This is how it looks like when you open it. And here again, the demand side is what we will define first when we start to build our model. And then we will see how can we supply it in the best possible way from local resources or just utilizing the electricity grid. Yeah, perhaps after this like basic introduction on energy systems, we also want to think a little bit about why we actually, what benefits do we get when we think in a system and when we use an energy system model to actually model our energy system. I think from my experience, even also as a researcher, but also in my earlier work, working with communities, most important part is that we create insight. We understand the components better of the system, which components are actually part of the energy system. We understand how these components themselves work and how they interact with each other. What they cost, of course, that's another important part, not to forget. How the system interacts itself, the system with the surrounding environment. If you look at the community, thinking about increasing self-sufficiency, but how do like national or electricity prices impact on the ideas of our community group which wants to invest in solar PV or wind. So we are, of course, dependent on how the environment looks like. And then when we have built this model, when we have created this insight, which components we have there and how they interact with each other, then we can start to change things in the system, like thinking about energy efficiency solutions. Like what if most of the buildings move to heat pumps? How much more electricity will we need? Can we supply this additional electricity use through local generation? So that we can play around with the tool which we choose and simulate results. We can also look at different time periods. We look at when we start to build a model, we build what we call base case or reference case, like how is the system looking like today or perhaps 2 years back when we need to rely on statistical data, which is usually not available for last year, but perhaps 2 years back. That will be our reference case. But then we can start to look into 2020, 2030. We know there's a lot of technological development ongoing. Prices of solar and wind are dropping. So how will our system perhaps look like in the future? We look at population growth. It can happen that in the master plan, in the detailed plan, you decide there will be a new suburb in this area with about 300 homes. So how will this impact on your district heating system? Or there is perhaps the idea to make this new suburb completely self-sufficient. And that we can also implement in our model. So we try to use our model to identify pathways. How do we get step by step into a future which we want that the system looks like? Because today we mainly look at energy system development to a direction where we want to be. We want to have a sustainable energy system with as little as possible environmental impact, climate impact. So we want to achieve something in the future, and from that we perhaps do a backcasting approach, but then we go again forward step by step and see how these steps actually help us to get to the goal which lies ahead in 2030 or 2050. So our models, which we are going to build today and tomorrow, should help us, I'm not sure if you can read it, generate alternatives. And those alternatives should be, of course, plausible. We use technologies which are available today, even if some of them are perhaps still too expensive, but we know from experience as they gain market shares, the prices are going to drop, what we call learning curves, technology learning. And this generated alternatives we also call scenarios. So our scenarios, our alternatives describe plausible futures. And some of the stories we can create with using the model, with creating scenarios. We create the story of a high efficient community. So we waste as little as possible energy for heating, for cooking, for transporting ourselves from A to B. And we can change heating systems. We can replace fuels, like we keep our boilers, but we replace peat by biomass, for example, by pellets or wood chips. We introduce district heating, which I understand in Ireland only 1%, I think, of the building sector is connected to district heating. And there is huge potential to do more, not only in the big cities, but I think also in smaller communities, utilizing local resources, residues from forestry and agriculture. And as we have seen in one of the pictures before, can be very small district heating systems, supplying just a few buildings, but having a benefit of reducing fossil fuel use, etc. We can invest then, after we have done the above, we can invest perhaps in more expensive solutions, solar PV, wind, storage, electricity storage. Perhaps there is also a potential for hydropower within your community, mini hydropower stations, up to 1 megawatt or something like that. And then we can also look at policy analysis. What governmental policies do we have? What do we expect? For example, CO2 tax could be a policy which could perhaps drive the change from fossil fuel-based heating much faster. I'm also having a lecture position in the university in Bergen. They have, in Norway, for example, they have a policy that by 2020 there is no oil heating allowed anymore. And that policy exists since, I think, 2013. So they had the sector, the industrial sector and the building sector had 7 years to achieve this. And they are on a good way to achieve it by 2020, that all oil heating is gone by 2020. So energy systems models are useful tools, I think, which we can simulate future scenarios. And then we have a tool which can also optimize future combinations of solutions. It would help us, but optimization tools are much more complex and complicated. I think we are going to learn to use Energy Plan, which is a simulation tool, which can simulate all our ideas step by step and give us results, useful results. We can look at different planning horizons for 1 year. But we can look at 2020, 2030, 2050 by thinking about how would our economy grow, how would our population grow, and then implement these figures in the model and model that case 2030.